Hi everyone, today we're going to be doing notes on section 1.5, which is about literal equations. So go ahead and take a second to pause this video and write this down. All right, so the essential questions for this section is first, what is a literal equation? And second, how do they help us solve your real world problems? Ooh, that's kind of hard to say. All right, so the definition of a literal equation is, just simply put, an equation that has more than one variable. And remember, a variable is the letter, so it has more than one letter. A way that we see these in the real world is it helps us rearrange variables to solve problems that we want. So in different sciences like chemistry, engineering, taking measurements, etc., things like that. Say, for example, you want to find the volume of a cube or a rectangular prism. Really common places that we see both of those shapes is boxes for shipping. You're looking at three different measurements for those. You have length, width, and height. Or the volume of a cone. Think about ice cream cones. We see these all over the place in real life. So this is really going to come in handy and help us not only later in this class and other units, but in life as well. All right, so let's look at the first examples. So I want you to think about two different problems. Both of these look really, really similar, but if you notice, the difference here is the one on the left has just 2, and the one on the right has 2y. So the one on the left is like what we've been solving before when we're just solving for one variable. So let's go ahead and solve that one. So the first thing I'm going to do is multiply both sides by 5 so that I can get rid of this denominator. So then I'll have 3x plus 2 equals 35. Then we'll subtract 2 from both sides. And then we'll divide both sides by 3. And if you're not comfortable writing that without the steps of subtracting the 2 and dividing by 3, you can go ahead and write that out. All right, now for the second one. Now I have this extra added variable in here, and I want to solve for the x. So I'm still going to start this the same way, multiplying both sides by 5 to cancel out my denominator. And now I'm going to have 3x plus 2y equals 35. Now instead of just subtracting 2, now I'm going to be subtracting 2y from both sides. But I want to point out that this 35 and negative 2y, these are not like terms. Not like terms. Which means we cannot combine them together like we did here with the 35 and the 2. They have to stay separate. So 35 minus 2y. They cannot be combined together. Now the last step is to divide both sides by 3. Now I can either write my answer as x equals 35 minus 2y over 3, or I can separate that out and write it as two separate fractions, as 35 divided by 3 minus the 2y, divided by 3. So whichever way you prefer to write it is fine. So notice how much of a difference that made by adding in that extra variable with our two examples that look almost exactly the same, except this one had a y in it. All right, let's look at another example. So we're going to do a few of these now where we want to solve for the indicated variable. So for this first example A, I want to solve for the value of y, which means I need to get the y value by itself. So the first thing I'm going to do is subtract 3x from both sides. Oh no, my finger made that smear. Oops. Now, the reason why I wrote the x value first instead of at the end is because I'm thinking about when we are going to get into slope-intercept form, which is when we are graphing the equation of straight lines, and they're in the form y equals mx plus b. So that's why I wrote the x value first, just to practice for once we get to that section. Sorry, I wanted to rewrite that because it's smeared. It still looks kind of but it's a little better. All right, so the next thing we're going to do is divide both sides by 4. And again, you want to divide everything by 4. So the last example I showed it using just one big division bar. Now I'm going to show it if you divide the first term and divide the second term using 2 separate little bars. All right, so my answer is going to be negative 3 over 4x plus 8 over 4 is 2. So now it's in that slope-intercept form, which is what we're going to be using in later units, and also something you should have seen towards the end of the last school year as well. Okay, go ahead and take a second to pause and write down example B. For this one, we're going to be solving for the value of x instead. So I'm going to add 4y to both sides. And I end up with 1/2 x equals, now again, these are separate terms. They cannot be combined together. So 4y plus 5. You could have written it as 4 plus 5, or sorry, 5 plus 4y instead, if you prefer. All right, now for this one, I need to get this x by itself. So what's in the way is the 1/2. What you're going to do is multiply by the reciprocal. So for this example up here, I wrote showing multiplying both sides. Put the 5 on this side, put the 5 on this side. Now I'm going to show you, this is personally how I prefer to write it when I multiply both sides by something. Just put the whole thing in brackets, and I'm going to multiply the whole thing by 2 over 1. And when I do that, my 2 over 1 times 1/2 will cancel and leave me with just x, equals 2 over 1, which is just 2, times 4 is 8, and I still have that y, plus 2 times 5, which is 10. And there we go. All right, let's move on to another example. For this next example, I want all of you to try these 2 problems on your own. So same idea, you're going to solve for the indicated variable, and I give you 2 examples and tell you what letter you are solving for. So while you are working on this, since you all don't get to see my little pen cup sitting in front of me, I love cute little pens that have funny little things on it, either animals or food. So I'm going to put one of my pens next to here while you work on this, since you don't get to see them on my desk. All right, I'm going to go ahead and pause the video. You please pause it as well so you can work on these and then come back to check your answer. All right, welcome back. Go ahead and check your answers, see if they match mine. If they don't, go back and check my steps to see where you may have gone wrong. For the second one, I did 2 steps at one time, so I subtracted the 6 from both sides and added 4y to both sides at the same time. Your next example is going to be an example where you can see how this applies to the real world. So we're talking about the formula of circumference. Speaking of circumference, that's something that's round. And my pen, when you click it, the little hamster thing goes around, which is funny. Stuff like this really entertains me. And it makes me sad that you all can't see it sitting on my desk. So I'll show you a random little funny pen once in a while. All right, go ahead and pause this and write down this example and part A, and then we will come back and solve it. All right, so for part A, we want to solve the formula for R. So first thing I'm going to do is just rewrite this as C equals 2 pi R. And we're treating pi like any other number or variable. Just leave it alone, leave it as is, leave it written as pi. Please do not replace it with 3.14. Just leave it as pi. All right, so I want to get the r value by itself. So the 2 and the pi are multiplied by it. So to get those out of the way, we are going to divide both sides by 2 pi. And I'm going to do this all in one step because it's going to make it a lot easier than dividing by 2 and then dividing by pi. All right, and just for the sake of writing this in proper form, I'm going to write it as r equals. So r equals c divided by 2 pi. And that's my answer. We have now solved for r. I'm going to go ahead and pause this and write down part B. So part B, we learned that the largest yo-yo in the world is 32.7 feet in circumference. That is a huge yo-yo. And we are asked to find the radius. So we know, that the circumference is that. And we want to find r, which means we are solving for r, which we already did in part A. My goodness, I can't talk tonight. I'm sorry. Alrighty, so I'm going to plug in 32.7 where I see the C. So R equals 32.7 divided by 2 pi. All right, now I'm going to show you how to do this on 2 separate calculators. Give me just a second to grab it. Okay, the first calculator I'm going to show this to you with is the one that's really easy to read my screen on here. This is my graphing calculator. So I'm going to do 32.7 divided by 2, and then there's a little pi button on here, which I realize now I should have found before I started recording the video. Okay, so there it is. The little tiny light blue pi. So I'm going to hit second, the light blue button, and then pi. So now I get a pi symbol. So I know that my answer should be 5.2. Okay, let me show you on another calculator. By the way, my calculator has cats on it. So in case it wasn't obvious already that I love cats, a student painted this for me on my calculator, which is fantastic. All right, so let's do it with a scientific calculator now. So this is the calculator type that you're more likely to have. So 32.7 divided by, now I can do the parentheses on here as well, 2, and then we can see our little tiny pi symbol is, where is it? Here. So we don't need to push a second button for it. We can just hit pi. Close parentheses. Same answer, 5.2. Then, if we do it on your phone, when you open your phone calculator, originally your screen looks like this. If you turn off the auto lock and turn it to the side, you get a whole bunch more buttons on here. I'm not sure what the Samsung or Android phone calculators look like, but if you have an iPhone, this is what it looks like. Now, the tricky thing about doing it on your iPhone is you have to be super, super diligent to make sure you're typing in these numbers correctly with your parentheses, because it doesn't actually show you anything in the little number line. So I'm going to do 32.7 divided by, now I'm multiplying 2 things together on the bottom. So I'm going to open my parentheses, 2 times pi, and notice it automatically comes up. I need to close my parentheses and then hit equals. So the only bad thing about doing it on your phone is it doesn't show you all of those in-between steps with the division and the parentheses and all that. So you have to be really, really, really careful about typing it in. All right, so based on our 3 devices, we know that this answer is approximately, I put little squiggly guys because it's approximately, 5.2. But we're talking about a word problem here, so we can't just say 5.2 and be done with it. The radius, you can either say is or is about. Actually, let me say the radius of the yo-yo. I'll be even more specific. The radius of the yo-yo is 5.2, and we're talking about feet. And there we go. All right, we're going to do one more example. Last example, I want you to try this on your own. So go ahead and take a second and pause this. I'm going to pause my video as well. And please click to continue when you're ready to check your answer. Also of note, when I write this, W with a slash, that means width. That is a common abbreviation for width. So a rectangular prism with a volume. And then I abbreviated centimeters instead of writing out the whole word. All right, I'm going to go ahead and pause it. Unpause it when you're ready to check your answer. All right, here's your final answer for the rectangular prism problem. And remember, I do my L's as cursive, so it's really obvious that it's not a 1. So double check to make sure you got the right answer. And notice here I wrote equals instead of that little approximate squiggly thing. That's because when you plug in the equation, you get an exact answer. It's not this big long decimal that you have to round. It's an exact answer. All right, that is the end of our notes. Have a good rest of your day.